Example 4.5. Given the specification of the synchronous motor is 415 volt, 300 megawatt, 50 Hz, 0.8 pf leading, 4 pole, Y connected, synchronous reactance of 0.9 per unit, and its armature resistance is being neglected. The question is, assuming this motor operating at rated condition and all losses is negligible, estimate the internal generated voltage and output torque of this motor. First of all, we must find P power to find the rated IA of this motor. So P in rated equal to P out rated equal to S rated times PF. So 300 MW times 0.8 equal to 240 megawatt. And then we find V phase equal to VT over Z3, which if VT is 415 over Z3 equal to 239.6 volt. Then the rated IA of this motor is IA equal to IL equal to P over Z3 times VT times PF equal to 240 megawatts over Z3 times 415 times 0.8 equal to 417.36 kA. And then we find inverse cos times 0.8, we got 36.87 degree. So IA equal to 417.36 with 36.87 degree kA. And then we find the base impedance of this motor is Z base equal to 3 V phase base the power of 2 over S base. So 3 times 239.6 the power of 2 over 300 MV equal to 0.5741 milliohm. So we find the actual resistance at S 0.9 per unit times that we got from Z base 0.5741 milliohm. So the answer is 0.5167 milliohm. And then to find internal generated voltage, we use this formula EA equal to V phase minus J at S times IA. So V phase we got 239.6 volt minus J times 0.5167 milliohm times IA 417.36 with degree 36.87 kA. And then the answers we got EA is 407.33 with degree negative 25.06 volt. So we want to find output torque of this motor using formula of speed rotation of this motor. So 120 times 50 over 4. So the answer is 1500 R over mean. So to find output torque, T load equal to P out over WM equal to 240 megawatt over 1500 R over mean times 1 over 60 times 2 pi radian over 1 r equal to 1.53 meganewton meter.
Assalamualaikum and hello. I will continue with the question from example 4.5 for B. Evaluate the maximum possible output power of the machine and discuss the possibility to increase it and justify your reason. Okay, this is my solution for question B. I use this formula for Sigmoto from power flow comparison. Pmax equal to 3 V phase times EA over XS. Okay, V phase, this 3 times V phase 239.6 times EA 407.44 over 0 XS 0.5167 M. This value we got from the question A we calculated, and it's equal to 566.8045 megawatt. Okay, the power is higher because the contribution of larger field and magnitude of internal generated voltage, but does not affect the speed of the motor.
3 example 4.5 C propose the best method to start the synchronous motor since it is connected to a power system. Okay, the answer is the best method to start this synchronous motor is by using damper winding or amethyst winding. As the addition of field winding, a series of a solid conductor passes through each four poles. These solid conductors are short-circuited at each end of the machine. However, field winding is turned off. The damper winding will act like an induction machine cache winding and provide enough torque to accelerate the motor. When the motor reaches synchronous speed, the field winding is turned on and the motor synchronizes. It is providing a synchronous torque. Okay, last question. D. Initially, if the motor is supplying 300,000 horsepower at 0.85 power factor lagging, determine the maximum induced torque with all losses is ignored. Okay, first we list down all the info, which is we know that the supply is 300,000 horsepower and the power factor is 0.85 at condition lagging. Okay, first we must convert the horsepower to watt, which is we use this formula. Watt equal to horsepower divided by 0.00134 and we get 223.88 megawatt. Okay, since all the losses are ignored, so we use this value as a Pout. So the formula is torque max equal to Pout divided by Wm, and then it is equivalent to 223.88 mega divided by 50 pi, and we get the answer is 1.425 meganewtons meter.
Example 4.3. Question A. Based on your understanding, briefly discuss the common approaches to supply the DC supply to the rotor winding in rotating synchronous generator. First approach is supply the DC power from an external DC source to the rotor by means of slip rings and brushes. Second approach is supply the DC power from a special DC power source mounted directly on the shaft of the synchronous generator. The ABC Industries has installed 3 steam generators to provide steam process and also to use some of its waste products as energy. Since there is extra load capacity, the MOHD has installed 3 50 MW turbine generator, 2 pole wire-connected synchronous generators with a synchronous reactance of 1.10 ohm and amateur resistance of 0.03 ohm. Generators 1 and 2 have characteristic power frequency slope SP of 6 megawatt per hertz, and generator 3 has a slope of 8 megawatt per hertz. The question is, determine the total power that has been supplied by generators if the frequency system is 61.5 Hz and no load frequencies of generator are 63 Hz. Okay, the given from the question is G1, generator 1 and generator 2 have a same slope, which is equal to 6 megawatt per hertz. Generator 3 is equal to 8 megawatt per hertz, and frequency system 61.5 hertz and no load frequency equal to 63 hertz. So we want to find the total power. Total power equal to P load equal to P1 plus P2 plus P3. So P, the formula is power from generator equal to slope times no load frequency minus frequency system. So SP1 times F and L1 minus frequency system plus SP2 times FNL2 minus F system plus SP3 times FNL3 minus F system. So we insert the given value into the formula, which is we got the answer is 30 megawatt for total power.